So now we're going to kind of just kind of dip our toe into the world of trigonometry. So trigonometry generally is the study of angles. Um, and you kind of start out doing trigonometry with triangles, and then you kind of open it up to actually doing trigonometry on a circle. So we're going to look a little bit about how angles are measured, a little bit about the basics of that right triangle trigonometry and how it relates to a circle, and we're going to look at the graphs of the trigonometric functions. So we're not going to get too deep into a lot of it. We're just kind of look at the surface, because perhaps unsurprisingly, trigonometry really doesn't come up in statistics all that much. I mean, if you dig deep behind it, you can find some maybe surprising results that relate statistics to trigonometry, specifically anywhere where like pi comes up, because pi comes from the circles. Circles are related to trigonometry. So in things like the normal distribution, for example, pi does come up. So it's there, but it's in the background. It's not, super useful in like computation, stuff like that. So we're just going to look at the basics of this trigonometry. So first things first, how do we measure angles? Okay, what do we even mean by an angle? Okay, so of course we have two lines. It could be two rays, which means lines going in only one direction, or it could be actual lines and maybe they intersect at a point, right? It doesn't actually matter. The part that they form right here we call an angle, right? And we can measure that angle. The typical way that we measure angles is with degrees, right? So we would say how many degrees it is. Maybe this is like 30 degrees. I don't know. We could get out our protractors and we could actually measure it if we wanted to. Okay, so we typically measure angles counterclockwise. So we would call this the initial side and this the terminal side. Okay, I'm gonna get rid of these parts, and we start right here and then we open up counterclockwise. So that's why this is a terminal and this is the initial. We can call this a vertex. Another use of the word vertex. Okay. And of course, there's some special angles. You have your 90-degree angle, which we represent with a drawing like a square right there. So this is 90 degrees. If we just have two rays kind of back to back like this, we would say it's 180 degrees, right? And if let's say that we start right here and then we open up in a full circle, really bad circle. Let's try to make it more circular, perhaps unsuccessfully. And we end up back at the same place. So we make a whole circle. We call that 360 degrees, right? So an entire circle is 360 degrees. Okay. Now, degrees is a little bit arbitrary. Like, why are there 360 degrees in the circle, right? So 1 degree then would be 1/360th of a circle. Okay. So, we kind of just take it for granted, but if you really think about it, it's just kind of weird. It's like, why do we use this number, right? Maybe just because it's nicely divided into 4 parts, so you can get to that 90 degrees easily. Who's to say? So we come up with this other measurement for a circle, perhaps a better measurement, one that's a little more common. Okay, let me use a circle tool here. So Let's go ahead and look at big circle here. Well, let's say that we have this circle and it has a center, okay, and it has a radius of 1, okay. So the radius of a circle is half of the length of a circle, right, with the full length of a circle being the diameter. So if we want to know, well, how far around is the circle? In other words, like if we were to start right here on the edge here and we traveled around the whole circle, how far would we go? Right? And that's another way of saying what's the circumference of a circle. Circumference of a circle is known as 2 pi r. 2 times pi times r, where of course pi is 3.14, approximately 3.14, I should say. So the radius here is 1, so the circumference is 2 pi. Okay. So if we go around this entire circle, if we travel around the whole thing, we would travel 2 pi. Okay. And that was basically the same way we were measuring degrees. Okay. If we start right here and we kind of open up and we just keep going and keep going and keep going, then we will have measured 360 degrees. So this is an equivalent measurement for that angle based on how far we travel on the circle in order to make that angle. Okay. So 360 degrees is equal to 2 pi, what we call radians. Okay. So we call it radians from the word radius for the radius of the circle, right? So it's measuring how far along we go on that circle. So for example, if we're looking at 90 degrees, okay, we know this is 90 degrees. How far in the circle are we going? Well, if we're traveling along this circle, then we've gone 1/4 of that 2 pi. So 2 pi over 4, which would be pi over 2. So to travel the whole circle, you're going 2 pi units. Then to travel to the 90 degree mark, you're traveling pi over 2 units. So we would say that pi over 2 is equal to 90 degrees. Pi over 2 radians, I should say. So let me maybe write that. Pi over 2 radians equals 90 degrees. Okay. Because that is how far we travel along the circle in order to get that angle measurement where you're opening up 90 full degrees. Okay. So if you look at your calculator, whatever calculator you have will usually have a button to switch between degrees and radians, right? And this is what that is. Okay. So the radians measurement is based on the circumference of the circle. Okay. So if we want to convert between them, for example, if we want to say, okay, well, what's 1 radian in degrees? What's 1 radian in degrees? You'd say, okay, well, we know that 360 degrees is equal to 2 pi radians. Okay. So if we just divide both sides by 2 pi, then this will tell us that 360 divided by 2 pi, which is about 57.3 is equal to 1 radian. Okay. Maybe we want 180 degrees, or let's just do a random one. Like let's just do 60 degrees, for example. 60 degrees in radians. Okay. again, we know 360 degrees equals 2 pi radians. So what could we divide this by to get to 60? Okay, we could say this, we could divide it by 60. Let's just do 60. So we'd have 60 degrees equals 2. I'm sorry, we're dividing by 6, not 60. All right, 360 divided by 6 is 60. So 60 degrees is equal then to 2 pi over 6 radians, which is pi over 3 radians. Okay. And this is an important one because 60 degrees is an important angle if you study triangles at all, right? Similarly, 30 degrees is pretty important, but we can think 30 degrees is half of this, so 30 degrees is going to be pi over 6 radians, half of pi over 3. Okay, so 30 degrees equals pi over 6 radians. Okay, we already saw 90 degrees equals pi over 2 radians. So another important one is 45 degrees, and that's half of this. We can see this is pi over 4 radians. Okay, so they're both measuring the same thing. We can convert back and forth between them rather easily using this equality right here. The 360 degrees equals 2 pi radians. From there, we can get to any measurement that we want to.